Hi, I'm Francesc Campoy, and this is Just for Funk. Welcome to episode number 28 of Just for Funk. Today we're going to continue with what we were doing last week, actually 2 weeks ago, and we're going to try to figure out which of the functions that I proposed to merge n channels is the fastest. And in order to do that, we're going to be using Go benchmarks. Does that sound fun? Let's get started. So I'm going to continue with the same code that we had last time, which is right here. Let me make it a little bit bigger so you can actually read it. We had this code and we were running it, but we were not really testing it or anything. We just like testing it by running itself. So what I'm going to do is I'm going to convert this program in actually some tests. And I'm going to create a first main test, main underscore test.go. And that's going to be also package main, because you can indeed define tests in the package main. I'm going to say test merge. And as every single unit test, it receives a testing.t, a pointer to testing.t. And I'm going to use as chan 1, 2, 3. So let's do 1, 2, 3, 4, 5, 6. And as chan 7, 8, 9. And let's call merge on all of those. And now what I want to do is I want to verify that I receive all of the values and not any other value or it's repeated or anything. So what I'm going to do now is I'm going to have a map that keeps the number that I've seen and whether I've seen it or not. And so for value range in C, if I had already seen this, then I'm going to say saw this value at least twice and the value is V. Then I'm going to always mark it as true because I've seen it. And then at the end, I want to make sure that I've seen all of the values. So I'm going to go for 1, 2, 9. And I'm going to say if not seen of I, then didn't see I. Cool. So now we can run this test and verify that this is correct. Cool. So this passes, which is good. This is taking very long time, which makes me think about the fact that if I'm not mistaken, as Chan is actually sleeping. Let's remove that because otherwise our benchmarks will not be very useful. Okay, so let me run the test again. So we run the test and now it works. Cool. So, and it's much faster. So now what I'm going to do is I'm going to convert this into a benchmark. What do we need to do? Actually, not that much. So I'm just going to copy paste it, and instead of test, it's going to be benchmark. Instead of T, it's going to be a B. And then we're going to need to iterate how many times we're going to need to iterate b dot n times. And we're going to do this over and over and over and over and over. T doesn't exist. So now it's going to be a B. And this is now a valid benchmark. So we can run the benchmark and see how long it takes in order to run this thing. And we see that it's taking almost, let's see, almost 10 microseconds. So almost 10,000 nanoseconds, which is almost 10 microseconds, which is cool. So now we could say, well, now that we know this, we can check with merge reflect and compare it, right? Like we can do run benchmark. The previous one was almost 10 microseconds. This one is almost 20. Therefore, there you go. This one is fastest. Cool. But is this enough? Not really. Like I'd rather have a better idea of how this is. So what I'm going to do is I'm going to use multiple sizes to see, because maybe, who knows, when we have when we have 3 channels, one is faster than the other, but maybe when we have many of them, the thing changes, right? Because after all, maybe since we're creating so many Go routines, 1 per channel, for one of the cases, maybe that's slower. So what I'm going to do is I'm going to simply go and let me move back to merge. I'm going to add from n 1, n is n times 2. We're gonna be doing b.run, and this is like the sub test. We have sub benchmark, same thing. So b.run, we need to give it a name. I'm just gonna simply say the name is gonna be the integer itself, and then the function is gonna be testing.b, and we need to put this here. Cool. So now if I run this benchmark, I should be able to see a bunch of different results. So you see 1, 2, and we see that it's taking all the time the same amount of microsecond. That's kind of weird. Well, it kind of makes sense because actually we're not doing anything with that n, right? So what we want to do is basically say we are not going to check for the values because we don't really care about the correctness of the algorithm. We've already proved that with the test. We are going to go over all of the values though. So we can do that by simply doing for range over C, that to make sure that we actually finish every time, which is good. So we're gonna also move that. And then what we need to do is we actually need to create n channels. So as many channels as n here. So what I'm going to do is I'm going to say chance is a make of int of the size, and then for every single time we do the iteration, we need to initialize those channels to something new. So I'm going to say for I in channels, channels of I equals as chan of let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, because why not? And then we're going to pass those channels here. So chance dot dot dot. Cool. So now we create all of the channels that we need, as many as we need, as many as we're saying we're using, and then we merge them. So now when we run our benchmark, we should be able to see that over when n increases, the value increases. And it's kind of doubling, so that looks pretty good. We can also see how many allocations we're getting per second, which is pretty good, per operation, sorry. And we can see, okay, so it's going up. That's pretty good. And now we should run the same thing with the other benchmark, right? With the merge reflect. But even better, my recommendation is, well, we already have these, we already have these benchmark per size. We can also do a benchmark per function. So something that is kind of cool when you have multiple implementations of the same function is they also have the same type, right? So you can declare a list of, I'm gonna say name, which is a string, and the function itself, which is gonna be a function that given a list of channels of integers returns a channel of integers. That is the type that we had. And actually I'm going to initialize it to say we have the one that uses Go routines, which is merge. Sorry, this is what it should look like instead. Whoa, let's go here and here. Okay, and the other one's gonna be reflection, and it's merge reflect. So now we can do, let's do it for f range funcs. We are going to use f, let's see, we're going to add the name here. So that's going to be f.name. and we're going to use the function here, f.f. And now if I just run this again, now we should see how we are using goroutines, and it's going to go from 0, well, from 1 up to 1024. And we can see the number of operations, the number of locations, stuff like that. But I'm actually going to stop it because instead I wanted to show you how to run it directly from the command line. So you would do go test. So go test would just run the test. But if you do dash bench and then a regular expression that matches all of the benchmarks that you want to run, for all of them, a dot definitely makes it work. So now we run it and we're gonna see that we were not benchmarking memory because I don't care about it that much. I just care about the time. So let's see how it works. Cool. And then we can simply copy this, create this here. What I'm going to do is I'm going to remove all of the things here. And then I'm going to remove this. I'm going to remove the 4. And then I'm going to remove this part. So now we have the sizes and the times. That still didn't work really well. So what I'm going to do now is also simply remove all the things in the middle. Going to copy only the times, put them here. And so we have 2 columns. We are going to add on here, goroutines and reflection. And the size is 1, 2, so equals this times 2. And now I can take it down. Cool. And now, in order to understand what is going on, I can insert a chart. And this chart's going to look something like this, but we're going to say, yeah, use column A as labels and use row 1 as headers. And now we can see that one is indeed way worse than the other. How much? Well, so much that here, let's see, here, this 1, 2, 3, 1, 2, 3, 1, 2, 3, it's incredibly bad. So yeah, the reflect function apparently is not good at all. Using goroutines works much better, up to at least 1024. Okay, so before we finish, I wanted to show you one more option that someone proposed. Someone said, hey, what if you used the merge true to basically create a tree? So the one that we talked about in 2 episodes ago about why are there nil channels. What if we get that function that is able to merge 2 channels? And if you want to merge 4, what you're going to do is merge 2 and 2 and then merge those resulting 2 into 1. So basically create a binary tree of channel merging. Would that be faster? And I do not know. So we're going to write it really quick and do a benchmark more. So let's do it really quick. I'm going to get first, I'm going to cat the one from episode 26. And there was, this is our merge. And I'm going to call that, whoops, I messed it up. I'm going to call that merge 2 because it merges only 2 channels. And now I'm going to do a func merge rec for recursion that given a bunch of channels, same as we had before, returns a channel of integers. Looks the same, yeah, okay. So what we're going to do is we're going to see what is the size of the number of channels we've got, and according to that we'll do one thing or the other. So let's do a switch on the length of the channels. For the case where we have 0, what do we need to do? Well, we need to send a channel that is closed already. So we're going to create a channel of integers, we're going to close it, and we're going to return that. And that's pretty simple. Why? Well, because otherwise what are we going to return? If we return nil, it will be something that blocks forever. So I think this is the easiest way of doing it for the case of 0. For the case of 1, we're just going to return chance of 1. For the case of 2, we're going to return merge 2 of chance of 0 and chance of 1, and that is a 0, not a 1. And for any other value, if we get more than 2, what we're going to do is we're going to divide the slice into 2, and we're going to call this recursively. So I'm going to say that m for the middle is len of chance divided by 2, and we're going to do merge rec of chance until m, and then merge rec of chance from m on, and then finally we're gonna merge those two. So we're gonna do return merge 2 of this and this, and with this we should have everything to get we should have everything together and working. What I'm going to do is I'm actually going to modify my test to make sure that this still works, and I'm going to use the funcs that we had before. So the funcs here, I'm going to add one more, which is recursion, which does merge rec, and I'm going to do for f range funcs. Let's move it here. We're going to do t.run f.name func t testing t, and we are going to call the function here. We're going to call merge f.f. So now when I run this test, we should be running actually 3 different tests, except that was way too fast and not enough detail. So I'm going to do this go test-v. We're going to see that all of them passed. There was a little bit of complaining about logging stuff, but that's okay. I will ignore that part. Actually, we will not ignore it, because otherwise we're going to have way too much stuff when we run it for the benchmark. But now, since my benchmark was working with funcs, and what I've done is just add one more, if I do the same thing as we did before, this should just simply work. So we should get now, rather than having 10 times 2, we'll have 10 times 3 cases. So we have 30 benchmarks running, even though I wrote a single function. Okay, so now we should soon see whether this one is faster or not. That was really fast. This one not as much, maybe. This is pretty fast. I'd say that this is definitely faster than reflection. I don't think it's faster than having go routines, because this still creates log n go routines, probably log n. I'm actually not completely sure, but okay. So we're gonna do the same thing as we did before. We're going to do some pre-processing to make sure this actually works. So that is the size. We don't need the size. I'm just going to drop everything other than the numbers, and then copy those numbers into, let me zoom out a little bit, because it's too hard to to follow with this. Okay, so I'm just going to do go routines, reflection, and recursion, and I'm gonna get the values. Recursion, let's make sure this is actually valid. The data range is going to go until D now, and now we have one more, and the rows are valid and everything is valid. So now we can zoom in and see that indeed recursion is much better than reflection, but mostly because reflection is actually really bad. If we remove reflection, we can still see that they're growing pretty much, I'd say linear. These are two are linear. The other one is probably exponential actually. And it works pretty well, but recursion is still way slower than go routines. This is the end of the episode. I hope you enjoyed it. Sorry for releasing it one day late. I was really busy. I'm in Madrid right now at the Sourced offices. That is Alan Turing up there. And we have cool rooms all around, but they're not really prepared for me recording, which is why the audio, I'm hoping for the best, but I think it's going to be a lot of echo, and the video is going to be my mobile phone. So anyway, thanks for watching. Please subscribe. And as always, see you in 2 weeks.